Welcome. Today we're going to be taking a look at how we can use SQL or Squirrel to do some subqueries to basically so we can get more data from data and even more information. Just a quick reminder before we actually go into detail, we want to review the statement order when we're talking about our database queries. So again, when you write this query out, it starts off with select, then your from or join on clauses, your where, your group by, your having, and order by. Of course, all of those except for the select and from are optional, but that's the structure of how we order them. However, when we execute them, remember we start with a from/join on clause sequence, then we go to our where clause to restrict the rows that we're going to be working with, then we go to group by, and that's going to coalesce the results into the groups that we're attaching that we want to actually work with, then having if we want to restrict rows based on this aggregate function. Finally, we're going to extract our columns by using the select clause, and if we really need to, we can order it using order by. Now a subquery, what we're really doing is it's a complete entire query, but we surround it by parens so we can use it somewhere else inside my query. Now, again, just like when we're doing joins, we really want to make sure we use a good alias for this because we actually are referencing an entire table's worth of information that isn't already specified. So we need to give a good alias, otherwise we're going to have a chance of getting confusion. So again, as always, aliases, great idea. You can basically put a subquery anywhere inside an SQL query, so it's really quite nice. They have a lot of different functionality. You can work with it. You most commonly see them in the from or join clauses, the select clause, or the where clause, because that's where you're going to do the most amount of work with them. And so those are the three we'll be specifying as we go through the lecture today. Now the subquery types, one of the first ones we have is the easy one. It's a scalar subquery, so it basically gives you a one-by-one table, a single value, pretty nifty. A multi-row subquery is going to give you a table itself with multiple rows, or an actual row of values with one single multiple columns on one row, or multiple rows and multiple columns. We're getting a full table's worth of information. And the next one we have is the correlated subquery. This is the most complex of the bunch, and it references the outer table and the inner table as part of the query, and so it executes for each row of the table. So you're going to be generating values over that. And one of the nifty things about this is it actually has an execution time attached to it because you're running the same query at different times, so it actually can have maybe a different executions time. The most powerful, however, of the subquery types is the inline view. And the inline view is because it creates an entire table we can use for an entire set of queries on our own in our from or join clauses. And we'll talk about that one as we go through. First, we want to talk about the scalar subquery. So the scalar subquery, we want to answer a single question. The most common way I see this is when I'm using it in, say, for example, I want to find a where clause matching a specific value of an average, sum, min, max, or count of a column in some other table. And so I want to match that on that. Because I can't just put that in a having because that's a whole separate query I have to actually do. So I have to do the subquery first and then put that as the result that I'm comparing against in a where clause. So it's a little bit different thought process. Calculated value can also go inside a select clause. I'm going to just calculate that for a scalar that I'm repeating for every single value inside that. And what's interesting to know, you can make a correlated subquery also be a scalar subquery. And we'll see that as we go through the examples. A multi-row query is going to match multiple values. And we match that with either the in, the any, the sum, or the all keywords. And because we're using the in, any, sum, and all keywords, we can't use the symbols like equals, less than, greater, etc. And so we see this in an example right here in our where clause. And I'm going to say field name is in, and then I do my subquery, and that gives me a single row set of values. So I can have, oh, here's all my values. I'm working with that. Separated by commas, just like an in clause normally would be. And so I can use that with a single row with that. I can also have a multi-row and multi-column in my where clause. And so if I have multiple rows and multiple columns, I can get that separated by commas like this by using a where right here. And I separate them so I have my field 1, comma, field n, and then for many fields I need to work with, and then my in keyword, and then my subquery results. And so it'll match all of them. So if I have a 3 column subquery, I'd have to have 3 fields in my parens before the in clause, just FYI. We also have the any and sum keywords. The any and sum keywords are basically, is there any match? Should we match anything with this? And we use those in conjunction with the relational operators like less than, greater than, less than or equal to, or greater than equal to. And these are actually the same thing. Any and sum, you just pick one. I like any, but if you want to use sum, cool, great. Just pick one and stick with it. Don't mix and match in your query. That's bad. You want to check to see in this case if the field and the operator matches against any of the values from that subquery. So field name, operator, any subquery. Val.score is less than any subquery results. Demo.value is greater or equal to any other subquery results. And so this would be worked with, say, for example, in your where clause where you're limiting the results on that. The all keyword is also used in conjunction with the relational operators with less than, greater, and greater or equal to, or less than or equal to. And it checks to make sure it matches against all of those results. So you have to make sure that every single one is the same type of value. In this case, field name operator all subquery. So like vol.score is less than all, and then pass it the subquery. So it's going to make sure it's less than all those values in that entire table's results. So just as an FYI, if you're using the all, it has to match against all of them. I know the word matches, but A correlated subquery, however, is the most complex one we have to do. And this one executes for every row of the outer query. So I have an outer query and an inner query, and it executes kind of like a nested for loop in Java or Swift. And so you're really easy to identify these visually by the reference of the outer table and the inner table subquery information. And so when you look at the aliases, that's the quickest way to find that. And a subquery, because it's and a subquery, because it has that outer-inner relationship, we can't run the subquery on its own because it has to talk back to that outer query. So that's another way we can see I can't just simply extract out that mini query and run it on its own because it's talking to that outer table the entire time. We can see an annotation right here of a correlated subquery. I'm going to select the exp.exporter name and then my subquery. I've select count star from cells S, where s.export ID is the same as x.export destination code. So if the export ID and the export destination codes have my outer table and my inner table both matching, and I reference that as cells count, and I'm selecting that from the exporter's exp. And so you can see I'm using the outer and the inner reference on there, so I have that idea of a correlated subquery. So that happens for every row inside that query, I'm generating the value each time. A little bit different than what we've been working with. An inline view, however, is the most powerful one of the subqueries. And this is any subquery that's going to fit inside the from or join clauses. And you definitely, as like I always say, you want to make sure you alias these for ease of use. We use an as command on columns names so we can ease any disambiguation, because especially when you're using an inline view subquery, you want to make sure that you have a good name for that subquery's value so you compare against the other query's value when you're talking about names of stuff. And it's really helpful for building complex solutions or complex questions, and really great for filtering results on a complex problem. I hope this is helpful. Cheers. Have a great day. We'll see you next time. Bye-bye.